We're now going to walk through the implementation of the ThreadJoinTest case study. This case study demonstrates the use of modern Java functional programming features in conjunction with Java thread methods. You can find this implementation in the ThreadJoinTest project in the CS folder of my Modern Java GitHub repository. So here we are in the ThreadJoinTest project, and let's go ahead and open the ThreadJoinTest file. This program implements an embarrassingly parallel app that searches for phrases in a list of string objects, each containing a different work of William Shakespeare. It demonstrates the use of modern Java functional programming features such as lambda expressions, method references, and functional interfaces in conjunction with Java thread methods, such as the thread start method to run threads and the thread join method to wait for all running threads. This test starts a Java thread for each input string, in other words, each work of Shakespeare, and uses the thread join method to wait for all threads to finish. This implementation requires no Java synchronization mechanisms other than what's provided by the Java thread class. We'll start our walkthrough by taking a look at some of the fields defined in the ThreadJoinTest class. One of the fields is a string that contains the name of a file that has the complete works of Shakespeare. You can find this file over in the resources folder. And here's the file. If you take a look here, you can see that all the various works of Shakespeare are separated by @ signs, and therefore we can use regular expressions to split this file up into strings containing a separate work per string. There's another field here that contains the name of a file that contains a list of all the phrases to search for in the complete works of Shakespeare. Here's that file. This is the phrase list file. And this contains a whole bunch of famous quotes of Shakespeare, such as "off with his head," or "brevity is the soul of wit," or "all that glisters is not gold," and so on. We use these two file names to open up files and read in the contents and store them in lists of strings. We looked pretty carefully at the bar data factory get input method and the bar data factory get phrase list in earlier lessons, so we're not going to walk through them at this point. Instead, we're going to focus on the contents of the main entry point into the program and the methods it calls. The main entry point goes ahead and makes an instance of ThreadJoinTest and then calls its run method. The run method, as you can see, starts all the thread objects to perform the concurrent barred phrase searches. Here's what run does. It first calls the ThreadUtils makeThreads factory method to create a list of thread objects, each of which will run the process input method, which is passed as a method reference to make threads. These thread objects will be joined after they process all the input string objects, which of course will be the works of Shakespeare. We'll take a look at the makeThreads factory method in a moment. After we get back that list of worker threads, we'll go ahead and iterate through them using the forEach method. And for each worker thread, we're going to pass the thread start method reference, thereby allowing each thread to start running. After all the threads are up and running and processing the works of Shakespeare looking for barred phrases, the main thread, that is the thread that's running the run method, will call the worker threads for each method once again, this time passing in a method reference to the thread join method. Thread join, as you may recall, is a barrier synchronizer that waits for a thread to finish before it continues. By putting thread join within worker threads for each, we effectively have the run method wait for all the threads to finish processing before the flow of control continues on. You can see here how we call the reThrowConsumer adapter function. reThrowConsumer is defined in the exceptionUtils class, which we see over here. And what it does is it takes a consumer that throws a checked exception, namely the thread join method, which can throw the interrupted exception, and it wraps it up in an adapter function, where we call the method on the consumer in the context of a try-catch block, and if the checked exception occurs, we convert it to an unchecked or runtime exception, thereby making it much cleaner to write the code that waits for all the threads to finish running. If you don't like this particular mechanism, here's the alternative way to do things using a try-catch block. As you can see, we use forEach, and this time we'd have to put a try-catch block around each call to join, catch that exception, and then convert it to a runtime exception. I don't know about you, but I find it much more concise and intuitive to see code that looks like this rather than see code that looks like that. Now that we've seen the overall flow of control in the run method in the ThreadJoin class, let's go back and take a look at some of the other methods it calls to understand how they're implemented. We'll start with the makeThreads factory method. This factory method is defined in the ThreadUtils class. The reason we put it over here is that this class can be reused in other contexts above and beyond the ThreadJoinTest. So let's take a look at makeThreads. makeThreads is passed two parameters. One is an input list, and the input list is the list of data to process, which in this case, of course, would be the complete works of Shakespeare, each element being a separate work, it's also passed a task parameter, which is a function, indicating how we can use functional programming features to parameterize a factor method like makeThreads. As you can see, the makeThreads factor method starts off by creating a list of worker threads implemented as an array list. And then it takes every element that's in this input list, like the works of Shakespeare, and for each of them, it goes ahead and it makes a new thread. And this new thread is going to have a runnable that is going to be created by calling the apply method on the task that parameterizes the makeThreads factor method. And when we apply that task, we join it or bind it to the input, like the work of Shakespeare, and that's going to be used as the runnable that's passed to thread. We then make a new thread and we add it to the worker threads list. And after we iterate through all the elements of the input list, we then go ahead and return that list of threads. Note that these threads are not yet started. As you may recall, the run method in ThreadJoinTest will start the threads when it calls the thread start method on each of the worker threads. Process input is really where the main functionality takes place in this program. As you can see, it takes a string, which corresponds to a work of Shakespeare, and it takes that string and it gets the title from that string. We get the title by using regular expressions. The getTitle method first creates a matcher that compiles a regular expression that matches only the first line of the input, since each title appears on the first line of the work. For example, if we come over here, you can take a look and see the first line of every one of the plays has the title, second part of King Henry IV, for example. Once that regular expression is compiled, we then create a matcher for this pattern by associating it with the input string. We then invoke the find method on the matcher to extract the title. If there's a match, it returns the match for the regular expression. Otherwise, it returns an empty string. After we get the title, we use a pair of nested for loops. The outer loop is a for each loop that iterates through each phrase that we're searching for. The inner loop then checks to see how many times, if any, the phrase appears in the input data. And to do this, it first starts by calling the indexOf method on the input string to find whether that phrase occurs. An offset that's returned that's greater than -1 indicates there's a match. And in that case, we go ahead and display the results. The for loop then updates the offset by calling indexOf again, passing in the phrase, as well as the offset plus the phrase length that matched, so it can skip over that and not have to worry about missing any other matches in the input. This inner loop continues as long as there's matches, and when there's no longer a match, the inner loop breaks out, we go back to the outer loop, and we keep going until there are no more phrases to find. Now that we've walked through the bulk of the method implementations in the ThreadJoinTest program, let's go ahead and run it and take a look at the output. When we click the Run ThreadJoinTest button in the IntelliJ IDE, it compiles and runs the program. As you can see, the output takes each phrase that we're searching for and then shows where it appears in a particular work of Shakespeare, what character offset. And as you can also see here, we have different thread IDs for each of these searches. What's interesting to note here is that within a given play, such as Hamlet, for example, it'll always occur in the same thread. So for example, thread 28 is always providing the matches for the Hamlet phrases. As mentioned earlier, this particular approach scales fairly well because there's a relatively limited number of Shakespeare works. There's roughly 37 or 38, depending on how you count them. So as a consequence, we're able to do this type of embarrassingly parallel concurrent processing by using Java traditional threads, which of course are platform threads, without running into any scalability limitations. Due to the modular design and implementation of this case study, it would be straightforward to substitute virtual threads for platform threads, but we'll leave this as an exercise for later assignments. So that wrapped up the walkthrough of the ThreadJoinTest case study, where we showed how to apply Java functional programming features together with Java threads.